let's get into a lesson on exponents and surds. Right, so let's talk about the laws of exponents. But firstly, remember, whenever we've got exponents, we've got first what we call a base, and this we call an exponent, right? So this would be the base, and this is what we call an exponent. And even though we usually just use this incorrectly in mathematics, the entire thing is actually referred to as a power. Okay, right, so let's get right into our laws. So the laws of exponents, right? So let's start with the first law. Right, so firstly, we know that in our first law, whenever we've got similar bases, when the bases are the same and we are multiplying, then we are going to add the exponents. Note that our bases are the same, both of them are a. So then in this case, we're going to have m plus n. We are adding the exponents whenever we are multiplying bases that are the same. Right, so if we take an example, so if I take x squared multiplied by x to the 3, right? So in this case, what happens? My bases are exactly the same. So we keep the base, we add the exponent. So in this case, that's 2 plus 3. So that will be x to the exponent of 5, right? So now we know that whenever the bases are the same and we are multiplying, we add the exponents. Right, so let's take law number 2. So when the bases are the same and we are dividing, we are going to subtract. So note our bases again are the same and we are dividing in this case. We keep the base and now the exponent that is in the denominator is simply going to change sign. Okay, so that's very important for you to note. So if I were, just to take an example, so 10x to the power 7 divided by, let's say, 2x to the power of 5. Okay, so note our coefficients. We're going to actually deal with the coefficients exactly as we always do with division. So 10 divided by 2 will give us 5. And in this case, again, bases are the same. That's x and x. So we keep the base. But what do we do to the exponent? We subtract. So that will be 7 minus 5. And so this will give us 5x squared. Okay, that's our final answer. So remember, whenever we've got similar bases and we're dividing, we keep the base and we subtract the exponent. Now, I think it's important for me to just make an example. So if I were to take, let's say, I've got 2 to the power of 4, right? And I'm dividing it by 2 to the negative 3. Note in this case, the exponent at the denominator, right, is negative. So this becomes, we keep the base. So that's 2. That's 4 minus, note, I am subtracting a negative 3. So in this case, that actually becomes a positive because in this case, we're going to say negative times a negative gives us a positive. So that becomes 2. That's 4 plus 3, right? Remember, a negative times a negative gives me a positive. So in this case, that will be 2 to the exponent 7. Okay, right. Now let's move on to the third law. So what does our third law actually state? Well, in this case, if we raise an exponent, right, or rather if we raise a power with an exponent, right, so in this case, we are going to take, let's say, an, and we are raising it to the power of m, right? So in this case, what happens? We are going to multiply. So this will become an multiplied by m. Right, this is very important. Note the difference between the first law, right, where we said we are multiplying, in this case, the powers. So if the bases are the same, we are going to add. This time around, we are raising a power with an exponent. So in this case, that multiplies, right? The exponents actually multiply. So let's take an example. If I were to say, well, we've got x to the power of 4, and we raise that to the exponent of 3. So this becomes 4 times 3. So x to the 4 times 3, and that will become x to the exponent of 12. I hope that makes sense, ladies and gents. Right, so let's go on to the next one. Right, so now, if we've got bases that are different, okay, and that are raised by an exponent each, okay, and we raise those to a certain exponent, let's call it c. Right, so what happens? We keep the base, we multiply each of the exponents. Right, so in this case, that will be a to the n multiplied by c, but it's also going to be b raised to the m multiplied by c as well. Right, this is very important yet again, ladies and gents. So if I were to make an example, if I've got 2x squared y 3, right? Y raised to the power of 3, and this is, let's say, squared. Right, now please remember, ladies and gents, that it is not only the exponents that multiply. In this case, the 2 as well, we need to square it. So you're going to have 2 squared x 2 multiplied by 2, that 2 and that 2 multiply with each other, multiplied by y, right, raised to the exponent 3 multiplied by 2 as well. So what's our final answer? This is going to be 4x to the power of 4, y to the power of 6. So this, again, very important for us to note that we need to actually raise each of the bases with that exponent. Right, now let's talk about the next one, law number 5. Right, I'm going to talk about the laws, and thereafter I am going to go into just the definitions, right? Now, if I've got something similar, I am dividing exponents, right, with similar, with different bases. Let's say raised, okay, let me say m there, raised to the exponent of c. Right, so in this case, when a fraction is raised to a power, right, both the numerator and the denominator are raised to that power. So it is a fraction, and I'm raising it to the power, and I am going to raise both the numerator and the denominator to that power. So this will be a to the power of n multiplied by c divided by b to the power of m multiplied by c. So that, again, ladies and gents, becomes very, very crucial. Okay, let's make an example. So suppose we've got 2x squared divided by, let's just say 5, okay, y to the power of 4, and we are going to raise that to the exponent negative 2, okay? So now I want you to note in this case, right, so this will become, now note, ladies and gents, that we also need to do the same with the 2's, and I'm going to show you something a little bit later on about raising to the exponent, a negative exponent. In fact, for now, maybe let's keep it positive before, so that I can show you that on its own. Let's just simply say squared there, and what happens? So this will be 2 squared, please don't forget. So that will be 2 squared x to the power of 2 times 2, okay, divided by, again, this will be 5 squared. Don't forget those coefficients, right, and raised to the exponent 4, but we multiply that by 2 as well. Okay, so note that this exponent here, or in this case, this power, actually multiplies into every single one of your bases, right? Every single one of your bases. Right, so what will this give us? That will be 4x to the power of 4, and this will be 25. 5 squared is 25. That's y raised to the power of 8. Right, so keep this in mind. Ladies and gents, that is it in terms of the laws. But now let's look at the definitions, right? So we're going to look at just a few definitions and how to actually apply them. Right, now, when it comes to exponents, we know firstly that whenever we've got any number or a base that is raised to a negative power. So in this case, if I take any number, okay, or a base in this case, that is raised to a negative power, right? So in this case, I can write this as a reciprocal with a positive power, okay? Right, so this will be 1 over a to the positive, raised to the power of positive n. Right, but note in this case that your base cannot be equal to 0. Remember, whenever we divide by 0, simply in mathematics, we say that the result is undefined, okay? So therefore, a cannot be equal to 0 in that case. Right, very important. So I can write this as, let's say, x to the power minus 2. What does this become? It becomes 1 over x to the power of 2. Okay? Right, so again, similarly, if I've got 5 minus 3, this will simply become 1 over 5 to the exponent of 3. Right, very important. Okay, and number 2, we know that any number that is raised to the power of 0, or any base, right, that is raised to the power of 0 should be equal to 1. Please don't forget that, ladies and gents. So it doesn't matter what the base is. X to the power of 0 should be equal to 1. If I take any number, let's say 453, right, and I raise that to the exponent of 0 or to the power of 0, that will simply give us 1. Please note, ladies and gents, that it doesn't matter how I can actually just represent this. Let's say 3x squared, and I raise that to the exponent of 0, that will give me 1 as well. Please again note that a cannot be equal to 0. Now, anytime that you raise 0, a base of 0, to the power of 0, right, that is simply undefined. Okay, so in mathematics, that would be undefined. Right, perhaps we can talk about this a little bit more. So please remember, this is illegal, right? Okay, so let's go to another one. Now, remember we said we're talking about exponents and surds. So remember, whenever we've got a surd, now what is a surd? In this case, when we've got something that is, under a root of some sort. Okay, so if I've got a to the exponent m divided by n, so I am raising, in this case, an exponent, or rather a base, with an exponent that is a fraction. Okay, remember in this case, the numerator, okay, would actually just remain, and the denominator is actually a part of the root. So what happens is that we can write this as, okay, so there's our a, right? The denominator, n, is the nth root. The numerator still just remains as part of our exponent. Okay, remember that we can write this conversely as well, meaning the other way around. Okay, so let's just take an example. So if I were to take okay, x to the power of 4 over 3, right? So what does this, how can I write this as a as a surd? So that means 3, that would become our root. So this would be the cube root of x to the power of 4. All right, I hope that makes sense. If we were to do this or apply this the other way around, let's say if we had 3 raised to the power of 4, okay, and we are taking the, okay, the cube root of that. So note we've got 3, and how can we write this as just a power in this case? So that will be the base of 3, we keep the base, right? Exponent of 4, that becomes the numerator, and in this case the root becomes the denominator in your power, right? So that would be 3 to the power of 4 over 3. Right, now ladies and gents, of course there are many others that we can talk about, and I just want to take some time and just talk about it a little bit because they actually become very, very important as we continue. Right, so number 4, I'm not going to stay as much on them, but I think they are equally important. Right, so if I've got, let's say, a to the exponent x to the minus n, I know that we've kind of spoken about this, but in this case we know that this will become a divided by x to the power of n. Please note in this case that our base, okay, this is a coefficient, our base is x, it's got a negative exponent or negative power, so we write it as in this case a positive power, in this case in the inverse. All right, so let's go to the next one. Now, similarly, if I were to have something ax to the minus n written like that, how can I simplify it? Well, again, I keep my coefficient, but it means that this guy can actually be written as x to the power of n. Notice in this case that I have now put it as part of my numerator, but I changed the sign of my exponent. Okay, so these are very, very important. So we are going to apply these a little bit more as we continue, right? But let me just share just 2 more that I think for me are very, very important. Okay, so suppose that I had, let's say, a fraction a over b, and I raise that to a negative exponent, right? Please note in this case that another way of actually writing this, and I can show you this, is actually going to be b over a to the positive exponent, okay? And the reason for that is that, remember, I could have easily written this as if it's a over b to the power minus n, right? This is the same as 1 over a over b to the power of n, right? And you remember, in this case, we can write this as 1 over a to the power of n divided by b to the power of n. And of course, if we apply our laws of division, then that becomes b over n divided by a over n, and as a result that can become b over a, all right, to the exponent of n. Right, very important for us to explore these a little bit, perhaps on the previous one, before I continue. Okay, so on the previous one we could have taken an example there and say suppose that you had 1 over, okay, let me just take an example on the side there, 1 over 3, okay, let's say x to the minus 4. Right, now please, I want you to note, ladies and gents, that we could actually just represent this. Now note you've got a minus 4 over there, right? So in fact, I think because we're running out of space, In fact, you know what? We'll take some examples later, rather for the sake of space. And finally, I want to take just the last one. Okay, so this is going to be a to the minus m divided by b to the minus n. Right, so in this case, how can I write this? Again, we can just simply swap them around. So this would be b to the n divided by a to the power of m. Right, ladies and gents, I'm going to leave it here, right? I want us on our next one, we are simply going to take a revision for the grade 10 exponents, right? And I want you to know how to apply these laws. Okay, I'll see you guys next time. Sharp, sharp.